Okay, so sorry for my hand. uh, Today what we did after the SR latch and T latch, we converted that T latch into this T flip-flop. And for that what we did is we're having this enable signal here, which will work as the clock signal in later part from here. So we will supply our clock signal from here. Basically I even tried doing it with where is it with this jumper wire. So here's this thing, and then there is a data signal. So this is basically data. As you can see, nothing is happening here because if you're even changing the data, it's just not doing anything, because we said with this AND gate we ended this data signal along with this, we ended this data signal with this enable signal. So until and unless these are one or in a state where we want to represent the one here, it's not going to change anything. So if one of these two remains at zero, the signal remains up here zero. So this NOR gate is being used here as the NOT. So as you can see, this pin number 8 and 9 are just feeding each other, and then pin number 10 has the output which is going into the input of this top AND gate, and this top AND gate also has one input also, which is coming from the enable signal. So enable signal, and then there's this data signal is just here, and it's one of its output. This is going right here. Okay, so as you can see, we have this. So this is basically the idea here. And whenever I try to change the data, since in computer what goes on and what we actually do with computers is we want to retain the data, we want to retain the state of the data. So even if we cut off the power, we want to make sure that the data is at either 1 or at 0, yes or no. So we want to make sure that, so we basically doing this thing here. So now our data is not changing until unless we have this enable. So we will also in the other next step, next iteration, we will try to bring the clock signal. But as soon as we have this one, and as soon as I press this, you can see it went to 0. It's not 1, it's 0, it's resets. So it is in 0 state, which is it's telling that now it stores a 0 instead of a 1. And what these two things here are doing is, this is a resistor of 1 kilo ohm, and then there is a zero point 0.1 microfarad capacitor. So these two are in series. As you can see, this is coming and then this is going to the ground. What it is doing is it basically is acting as a trigger signal or as a heartbeat. So whenever the clock changes from 0 to upper to high, whenever anything something like that happen, it triggers a very it's just a 0.1 second. So we are having 0.1 second of that heartbeat here, and it will just immediately switch to that state. So if we do this and if we try to change any of the state, it won't, because at that instant when we pressed it at 0.01 second, it was at 0, so it's gonna retain the 0. So if you want to store the 1, what we have to do is we have to press the 1 earlier and we have to retain that state. And if we change it, oh okay, so as you can see that if 1, and if I even try to change it, nothing changes. But if I leave it at there, you can see even if I left this thing later on after that, it remains at 1 no matter what I do with the data. But if I remain it at 1, the data is at 1, and if I do the enable signal, it's not going to change it. So even if I do this, and if I left it, and if I do this, you can see that it didn't change, because it just only it only took that input for 0.1 second. That's it. So we were able to have the delay just 0.1 second. It's gonna retain that state at that moment, just 0.1 second. Whatever the state is going to be the of the data signal, it's gonna retain that. So it is retaining it. And if we try to do what, if we try to have the 0 state here, and if I just disconnect one of the wires here quickly, if I reconnect it, oh wait, okay. uh, why didn't work? I did try it with jump wires and it was working, but it's not working. Okay, I don't know. I'm gonna see it. I'm gonna look at it, and when I will work for the remaining part where we were designing the 1-bit register, I'll I'll see.